Dear audience, my name is Viktória Barna, and the title of my thesis is Physical Training: How to Achieve the Optimal Level. I am a dietitian and an agricultural engineer, and here you can see my affiliation and my team. We have 3 ongoing projects. The first one is investigating the effect of regular training on bone-related biomarkers in healthy adult population. Why is this research important? We know that increasing physical activity and optimizing exercise is seen as an optimal way to improve musculoskeletal health. However, the relationship between biomarkers of bone turnover due to regular exercise is still unknown. It is still difficult to predict what type, intensity, frequency, and duration of exercise are optimal for bone health. Therefore, our aim is to study how musculoskeletal biomarkers are affected by regular training in healthy adults. To achieve our aim, we formulated the presented clinical question and PICO framework, and our clinical and research implication is to suggest optimal training protocols and find the underlying mechanism of different training types. We made our systematic search in 3 main medical databases, and here you can see our search key and the number of hits. After the selection process, we found 22 eligible articles that we included into the final meta-analysis. Our outcomes are osteocalcin and bone alkaline phosphatase as the 2 most investigated bone turnover markers, and body mass index and bone mineral density was a secondary outcome. We also made subgroups based on training type, intensity, and for this we used the guideline of the European Federation of Sports Medicine Associations. Here you can see the change in osteocalcin level after regular endurance exercise in healthy adults. We included more than 200 patients into this analysis, and we made 3 subgroups: high intensity interval training, and low intensity. In high-intensity training group, we found that high-intensity training has no significant impact on osteocalcin level, while high-intensity interval training has significantly increased the osteocalcin level. Low-intensity training did not have any impact on osteocalcin level. I would like to highlight this study where the difference was the largest in the high-intensity training group. However, the participants trained with very high frequency, which means they trained in high intensity and they trained very often, weekly, without any meaningful impact, while in the high-intensity interval training group, they trained only 1 or 2 times a week. In a low-intensity training group, the training period or the study period was 4 years without any meaningful impact on osteocalcin level. Here you can see the effect of regular training in body mass index, and we included 3 articles into the analysis, and this population was quite heterogeneous, and we found that during the analysis, regular training has a very strong decreasing trend in BMI, and the intervention group performed much better compared to the non-training group. However, the result was not significant. I would like to highlight this study where the difference was the largest, and in this study the average weight loss was 5 kilograms during the study period, which means a clinically relevant effect. Here you can see the change in bone mineral density during regular training. We made 2 main subgroups here, endurance training and power training, and we didn't find any effect during this analysis. And we also made subgroup analysis power training, where we found only 1 study with a little bit higher results. But in this case, the participants made high-intensity power training. So in summary, training type, frequency, duration, and intensity has no significant impact on bone mineral density, which is good because usually weight loss interventions ended up with bone loss, especially medically induced weight loss. So the conclusion of our study is high-intensity interval training significantly increased osteocalcin level, while other training types did not. And high-intensity interval training tended to decrease body mass index, but did not change bone mineral density. And the change in osteocalcin level rather influenced by training intensity, not duration, frequency, or session length. And only high-intensity continuous training reduced BMI. Our implication for practice is high-intensity interval training should be included to a balanced exercise plan, and implication for research is further studies needed to assess the effect of high-intensity interval on BND, especially because osteocalcin is just one marker, and the whole bone turnover process is a very complex thing. We have a lot of bone resorption and bone formation biomarkers, so further studies definitely needed to assess the effect of exercise on them. Here you can see the current status of our manuscript. Our second project is investigating the effect of training on microelement and vitamin levels in healthy population. Why is this research important? Because microelements are essential for physical and mental function, and physical exercise can alter their concentration, and this can lead to depletion as well. Cross-sectional studies shows altered microelement needs in regularly trained healthy adults compared to untrained. However, further research needed regarding the regular training effects. Although many studies explore nutrient intake's effect on exercise, little data is available, and there is no consensus how chronic exercise affects microelement needs, especially in healthy adult populations. Therefore, our aim is to investigate how microelement levels are affected by regular training. To achieve our aim, we formulated two clinical questions, one from microelements and one from vitamins. And here you can see our search keys and the number of hits in the three main medical databases. Both projects are in a data extraction phase done, so actually we are finished the data extraction both in the microelements and the vitamin pools as well. So in summary, we have three ongoing projects. Three of them are systematic reviews and meta-analysis. The first one is submitted, and the other two will be submitted at the end of this year. And please let me show you a slide about my additional activities. We have research collaborations with the Chinese University of Hong Kong, Academia Europaea, and the Hungarian Agricultural Universities. I also will present my results at the annual Congress of the European College of Sports Science and Semmelweis PhD Scientific Days. And I also very proud of my mentored TDK students. So I would like to thank you for your attention with the quote of Ashley Montagu. The idea is to die young as late as possible. Thank you very much.
Thank you for the presentation. Who has questions from the floor first? Yes.
Congratulations on your presentation. Based on your preliminary data regarding your last project, did you see a decrease in vitamins after training, or do you see any preliminary statistics regarding that?
We don't have preliminary statistics yet. We have
Use a microphone, please.
We have just finished the data extraction, so I think it is better not to answer this question now, because we don't have any concrete data.
Thank you.
Any other questions? No? I have a question. Did you take into consideration the type of endurance exercise or the duration of the exercise? Because I assume that there was differences in that as well.
Yes, when we made the subgroups, first we made subgroups based on exercise main type like endurance, power, or mixed. And in the subgroups, we consider the frequency, duration, and the intensity of the exercise. So we analyzed different subgroup, high frequency, high intensity, low intensity, and so on. So we made as much as we could. So if we had poolable data, we made a subgroups based on session training, duration, frequency, and intensity.
And so there were no differences in the results, because I was a bit surprised to see that there was no effect on the bone. I don't know which parameter.
It was very surprising for me too, but as I mentioned, it's not bad, because usually weight loss interventions lead to bone loss. So what we can see here, exercise has no effect on bone mineral density, at least, so there is no decreasing trend, and it is good. Okay. Because usually diets and medically induced weight loss can cause bone loss as well.
Any other questions from the floor? No? Yes?
Hi, I'm just wondering, what were these RCTs, or how would they, yes, and how do they measure compliance? Or how did they make sure that the comparator group is not doing
yes, they measured compliance. They were supervised exercise sessions. So they not just went home and do something. They had to go to the lab and do the exercise there.
And is there any ideas
and we only
prevent the other group to exercise? Because there might be an explanation of why you don't see any result, like differences. If the other group knows that it might have, they might do this even though if they are in the control group.
We only analyzed the group that finished the experiment, and we compared trained and untrained population. If it's the question, or what do you know?
If I understood correctly, there was a group who did one type of exercise and another group which was another type of exercise?
No, the other group did not train.
Did not train. And how did they make sure that they not train? I mean, it's because if they are also training, that might explain why you don't see the result as clear as you see.
So the intervention group was supervised, so they trained, and they also also instruct the sedentary or the control group to maintain their physical activity, and don't do any other type of exercise. So during the selection process or the randomization, it was tied to the participants not to train.
Thank you.
Yes, we have a question there.
Very interesting presentation, thank you. My question is, what age were these populations that you analyzed? Why I'm asking, because after a certain age, the bone turnover drops, and therefore I expect to see less of a result.
Yes, it's a very good question. Thank you very much. There were healthy adults above 18, but most of the studies investigated postmenopausal women, of course, but the age was, very different. So we had studies from every age group, like young people or older or after or before menopause or whatever, and we also have male and female studies. But based on this, the studies were very heterogeneous, so we made the subgrouping based on the type of intervention.
Thank you.
Okay.
Any other questions?
It's a little bit counterintuitive that regular exercise wouldn't impact on bone density. But do I understand it correctly that all the studies you analyzed are based on osteocalcine, which is a osteoblast marker, which would be counteracted if in many of these patients by osteoclast markers, which decrease bone density. Are there any studies that have determined a C-terminal telopeptide, for example, as an osteoclast marker? Or do these results correlate? Well, when I ran a department, we also used DEXA, low dose X-ray, or you can do it with low dose CT, and you can get not a surrogate marker, but the actual density of the bone. So Are there studies with DEXA that show the same thing, that only high-intensity training has an effect on bone density, or
we have
how do you
studies.
interpret that?
Most of the studies measured osteocalcin and bone alkaline phosphatase. Therefore, poolable result, what we can include into the meta-analysis, we only had for osteocalcin and bone alkaline phosphatase, but most of the studies are also investigated other markers like cross-linked peptides or other bone formation or resorption markers, or they analyzed the two together, and they often made a DEXA measurement, but this type of measurement is show the changes slower than the biomarkers. So the conclusion of the studies was that biomarkers shows something change in the bone turnover process earlier, much more earlier than DEXA or other measurements.
So if there are no more questions, thank you very much.
Thank you.
And